First thing we're going to talk about is domain. Now domain is all of your x values where your graph exists, and by default it's all real numbers. I can spell real. Let's try that again. All real numbers except ones that cause a denominator to equal 0, and ones that cause a negative number in a radical with an even index. Okay. Now this kind of grows as you go along. Like when we get the logs, we'll add a third one onto here and so forth. But for now, these are the only two we have. Now this first one, blah 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 denominator. That implies you have a fraction. Second one, blah 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 radical with an even index. That implies you have a radical. So if you don't have a fraction, you don't have a radical. Again, your domain is all real numbers at this point. So let's look at our first problem. We got f of x equals x squared minus 4x minus 7. And instructions are to find a domain. Well, we don't have any fractions, don't have any radicals, so our domain is negative infinity to positive infinity by default. Let's take a look at one with a fraction. We have f of x is equal to 2 over x squared minus 6x minus 27. Same instructions, find a domain. Now if you have a fraction, and this is for finding a domain, first thing we're going to do is set the denominator equal to 0 and solve it. So set denominator equal to 0 and solve. Well, in this case I have x squared minus 6x minus 27 and set it equal to 0. This factors using the PSD method. So this is x minus 9 times x plus 3. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set x minus 9 equal to 0 and x plus 3 equals 0. And we get 9 and we get negative 3. Now these are the numbers that cause us problems. For example, if I put 9 up or negative 3 up here, negative 3 squared is 9. Negative 6 times negative 3 is 18. 18 plus 9 gives us 27, and 27 minus 27 gives us 0. So these are the values we cannot have. So our second step is put a slash through the equals. So for our domain, x cannot equal to 9 and x cannot equal to negative 3. Now if you want to see how that's written in interval notation, we'd have negative infinity to negative 3, parentheses, union, begin parentheses, negative 3 to 9, in parentheses, union 9 to positive infinity. For purposes of my class, I'm happy with this right here. Let's take a look at this one. We got g of x is equal to 1 over x squared plus 9 plus 5 over x squared minus 9. Now if you have two fractions, well, it's still the same procedure. You want to set your denominator equal to 0 and solve. So I'll set the x squared plus 9 equal to 0 and the x squared minus 9 equal to 0. So we'll set both denominators equal to 0. Well, this is a perfect example of when to use a square root property, because we can very easily get the squared part by itself. So I take the 9 over to the right side, becomes a negative 9. Square root property says you drop off your squared and you put a plus or minus square root around the other side. But 3 times 3 gives us 9, and the negative gives us an I. Now, for purposes of finding a domain, you get i's, you can ignore that part. So we'll cross that out. Well, let's do the other one. Take the negative 9 to the right side, becomes a positive 9. Square root property, we drop our squared, put a plus or minus square root around the other side. And 3 times 3 gives you a 9, so square root of 9 becomes just 3. So, these are the values that cause us problems. X cannot equal to negative 3, and x cannot equal to positive 3. If you want to write an interval notation, it'd go from negative infinity to negative 3, union, negative 3 to positive 3, union, 3 to positive infinity. Well, let's take a look at one more fraction. So we've got g of x is equal to 1 over 2 over x plus 1 minus 3. Well, same idea. If we have a fraction, you set your denominator equal to 0. But in this case, we have two denominators. We have an inside fraction here. This is called a complex fraction, specifically a complex rational expression. That's where you have x's, but a complex fraction. So we got a fraction inside here. Well, it's got its own denominator, x plus 1. So we need to set the x plus 1 equal to 0. And then looking at the outer fraction, all of this is our denominator. So we're going to set 2 over x plus 1 minus 3 equal to 0. Well, on this one, take the 1 over, becomes a negative 1. And that's our first x value. On this one, this is a rational equation. And we get rid of the fractions first, multiply everything by LCM of all our denominators. We only have one denominator, the x plus 1, so we're going to multiply everything times x plus 1. So multiply times our first fraction, multiply times the negative 3, and we'll multiply times the 0. Well, the x plus 1 is going to cancel here and leave us 2. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. 0 times anything is 0, so that's going to drop away. At any step, combine together numbers. 2 minus 3 gives us negative 1. We're solving for x, so I'm going to take the negative 1 to the right side and it becomes a positive 1. And then divide both sides by negative 3. And we end up with x is equal to negative 1/3. So we have x equals negative 1 and x equals negative 1/3. These are the values it cannot be. So x cannot equal negative 1 and x cannot equal to negative 1/3. If you want to write that in interval notation, the negative 1/3 is my smaller number. Wait a minute. Negative 1 is, sorry. So let's go from negative infinity to negative 1, then union, negative 1 to negative 1/3, then union, negative 1/3 to positive infinity. You'll see a pattern here pretty soon with the interval notation. Always starts at negative infinity, goes to our first smallest number, union, our first smallest number, comma, our next number, and then union, and then that number, and then to positive infinity. Everything always has parentheses on it. Again, I'm happy right here. Now, the negative one's pretty easy to see. Plug that in, gives you a 0 in this fraction. The negative 1/3 is not so easy to see. You'd have to do some manipulation, but that also would give you a 0 in the denominator. Let's take a look at a radical. Here we have g of x is equal to square root of 5x minus 25. Same instructions, find domain. Well, this time, this is a radical with an even index. Now, your index is whatever number is in this little slot right here. If there is no number there, it's by default 2. So this is a radical with an even index. What we do is we set what is under the radical greater than or equal to 0 and solve. It can be greater than 0, that's positive. It can be equal to 0. It just can't be negative. So we'll set 5x minus 25 greater than or equal to 0. Now we're wanting to solve for x, so we'll take a negative 25 over to the right side, becomes a positive 25. Divide both sides by 5. And we end up with x is greater than or equal to 5. Now interval notation wise, that would be bracket 5 comma infinity. And I'm happy with that form, but again, you can do the other one if you wish. Now I've already saved these, so I'm going to go ahead and just start a new page. And let's look at the next problem. So we got h of x is equal to square root of x minus 5 plus square root of x plus 2. We got two radicals with even indexes. Well, we'll do the same thing. We'll set both of them greater than or equal to 0. Just like when we had two fractions, we worked with both denominators. Well, then we'll solve this. This gives us x is greater than or equal to 5, and this one gives us x is greater than or equal to negative 2. Well, let's think what this means, and I'll just work with integers because it's easier. X is greater than or equal to 5 would be what? 5, 6, 7, so on. X is greater than or equal to negative 2. That'd be negative 2, negative 1, 0, and so on. Well, let's look at this 5 here. If I put 5 up here, 5 minus 5 is 0. Okay, that's okay. 5 plus 2 is 7, that's okay. If I put 6 in there, 6 minus 5 is 1, that's okay. 6 plus 2, that's 8, that's okay. Let me put negative 2 up here. Negative 2 minus 5 gives us a negative 7. We cannot have a negative number inside of our square root. So this one right here, actually, we cross off, and our answer is x is greater than or equal to 5. If I put an interval notation, that'll go 5 to positive infinity. Now the best way, if you have two radicals like this, is do some test cases like what I just did and check that out. I'd be tempted to say it's always your larger number that you keep, but depending upon if you divide by a negative number, you may flip these around, and it isn't set in stone.